has helped us make an amazing start. It is now time for us to further deepen our understanding and have a better grip on the fundamentals. And for that, the team welcomes you to session 2 of Compose Camp, Introduction to Kotlin Continued, presented to you by Manjunath, our Flutter lead. I encourage the attendees for active participation and not refrain from asking doubts by turning on their mics or in the chat box when requested to do so. The slides of the presentation will be shared. Now here's Manjunath to tell you about object-oriented programming in Kotlin.
Am I audible?
Yes.
So, hello everyone. I am Manjunath, Flutter lead at JDSC. Okay, so in the previous sessions, we learned regarding the basics of Kotlin, right? So today we will be moving on to the new concepts and we will build our knowledge upon the basics that we learned in the previous sessions. Okay, so today we will be learning something called as object-oriented programming. In short, we can call it as OOPS. So if you are feeling oops, no pun intended, I haven't worked with any object-oriented programming languages. Can I still learn these things? Yes, absolutely. You can learn all these things from scratch. I will be teaching all the things from scratch, and at the end of the session, you'll be in a position to write your own classes and instantiate objects, right? Okay, so what is this object-oriented programming or OOPS? So as the name suggests, it's a way to represent the real-world entities or the objects via the programming languages. So what are these objects? So can we consider these objects as the literal real-world objects or the entities? Yes, of course you can. Object-oriented programming or OOPS is designed in such a way that we can represent these real-world entities using these programming languages. So that was a short intro regarding object-oriented programming. In this, we have various concepts. Before that, we need to understand like why do we need OOPS, right? So basically, suppose if you are building a large application, in that we have like several lines of code, right? So as the application gets complex and complex, it's become very hard to debug, maintain the code, etc. Right? So basically, OOPS helps you to divide the large program into smaller chunks, and this can be achieved using classes and objects. So in turn, it increases the programmer productivity. Since it increases the programmer productivity, it also reduces the quality of the software. And icing on the cake is it reduces the maintenance cost, right? Since what do I mean by it increases the programmer productivity? So it basically promotes reusability and reduces the redundant code or unnecessary code. Cool? Okay. So now we shall explore the OOPS concepts. So first in that we have something called as class. So what is this class? So basically class is like just a blueprint. What does this blueprint contain? So in our real world, this blueprint contains set of instructions, right? Like a blueprint might contain like the design to build a building or to manufacture a car. So it's basically a set of instructions to build a specific type of object, right? So if you consider this example, so now we will consider a blueprint to build a car. Okay, so this is a blueprint of the car, and as you can see, there are various attributes or functions that are mentioned in this thing. So attributes might be like the color of the car, the size of the or dimensions of the wheels, etc. And the features might or methods might be like the maximum speed of the car, like and whether it is a race car or whether it is a normal car, like that. So if you consider this blueprint of, we can say that this blueprint of the car will not occupy any space in this universe, right? Okay, if you are thinking like a science student, like since it is also a form of matter, it also occupies space. Well, if you consider the scale of this universe, this blueprint is literally like a sheet of paper, like a millimeter thick, right? So we can easily say that this blueprint will not occupy any space. Even in our computer science, these classes will not occupy any memory, right? So, so now we have got the blueprint, and then we will move on to the manufacturing process, right? So after manufacturing, the car will look something like this. So when compared to this blueprint, this occupies way more space in the environment, right? So we can say that classes will not occupy the space, but objects do occupy the space in the environment. So basically, as we can say, object is nothing but an instance of the class, right? So we build the object based on the blueprint that are all specified in the class. So example, this is a real car and it occupies space in the universe. And I think it is clear. Yeah, cool. Okay, now we shall see like how to create these classes and objects in Kotlin. Okay, for that we will go through a demo. Yeah, so here I have entered the Kotlin playground website, and to create a class, I'll use this keyword class, and this is the name of the class, car. So so as we saw earlier in classes, we have two things, variables or attributes, and one more thing is methods, right? Okay. So let's say we want to decide the color of the car. Let's say I declare a variable color and I assign it with some string red, right? Okay, then let's say I want to name the model of the car. Let's see, keep it as just a capital letter A. Then let's say the maximum speed of this car is 200. So these variables in object-oriented programming or inside the class is called as attributes. So let's define some methods. Methods are nothing but the functions, right? Okay, let's define one method. I'll define a method called as drive. And inside that, I'll print something like, so this is the sound of the car, right? Vroom, vroom. Okay, this is basically a method. And then I'll define one more method called as max speed. So if you remember, in order to specify the return type of the method, we need to specify something after the function name, like this colon, and return type is specified after this colon. So basically, we will be returning an integer data type from this function. Okay, now I will return this speed variable. So now I'll clear this stuff. So I will now. So this is a class, right? So this class will not occupy any memory. So now I will create an instance of the class, or you can say it as object. I will create a variable called car, or you can say it as, if it is confusing, you can say it as my car1. To create an object, you should specify the class name. Then you should close it with these small braces. So this will create an object, and this object will occupy the memory in the computer, right? So let's say I want to invoke a function on this object, car dot, okay, we have named the object as my car, right? My car1 dot. So if you click on, okay, yeah, see, there are various functions that you can invoke on this object, but let's say we will invoke this drive function. And since there is one more function in this class, that is our max speed, since it returns an integer, I will be invoking the same within a print statement. Okay, now let's run this. Yeah, so as expected, the drive functions returns this string, and the max speed basically returns an integer. And as we can see, the value of the integer is 200. So this is how you create a class and instantiate an object in Kotlin, right? Okay, I think this is clear. We will move on to the next concept. Okay, constructors. So basically, we will be using these constructors to initialize the members of the class. So if you are thinking, we can initialize in this way too, right? Like using variables or attributes. But what if we want to initialize, this is like after creating the object, like what if you want to initialize the object like during the creation itself? For that, we have something called as constructors. So basically, there are two types of constructor. primary constructor and secondary constructor. So before we move on to this type, let's understand the definition of constructor. So basically, a constructor is a special member function that is invoked when an object of the class is created, primarily to initialize the variables or properties. So if it seems confusing, do not worry. Like we will go through the code, then you will get it will make sense, right? Okay, basically it says that it's a special member function, right? So even though it looks like a function, it's not a function. It's just a function kind of thing. So it will be invoked when an object of the class is created to initialize variables or properties. So now we will see the two types of constructors. First, we have something called as primary constructors. So what are these primary constructors? So the primary constructor is initialized in the class header, goes after the class name. So as we can see, so this is how you declare a class. To define a primary constructor, you will be specifying the parameters of within the small braces, just like you do for the functions, right? Like you will be specifying the parameters within the small braces. So that's how you create primary constructors. Okay, we will see this. We now will clear it all this stuff. And let's say create one class called as class add. So since I want to create a primary constructor, I will be specifying the parameters or values within this small brackets. So I'll specify a variable called as a, that is of type integer, another variable b, that is also of type integer. So here inside that class, I'll declare one variable called as result. Since we have already gathered the values using this constructor, we will just use it, right? Like this, as simple as that. Okay, now let's try to create an object of this class. Let's say the object is, let's call the object as C. Then to create an object, first we should specify the class name. So if you try to execute this, there will be some error, right? So since it's a constructor, it will be expecting some parameters. So we need to pass two parameters of the type integer. So I'll pass two integers, 1 and 2. Then to access this result, I'll specify the object name, then type dot. Then after, if you type this, then after you can type this attribute name. Yeah, as expected, first an object will be created. During the creation itself, we will be passing two parameters, 1 and 2, and these parameters will be used here, and the sum will be returned and stored in this result variable, right? So this was regarding primary constructors. Okay, there's something called as init block. So basically, init block, as the name suggests, is used to initialize variables. So you might think like, what is the difference between this constructor and init block? So basically, the init block is executed prior the constructor is called. Like if you want to see some example, just a minute. Yeah. So basically, this is a primary constructor, right? Let's say before you want to store the result, before you add these two variables a and b. Let's say you want to add 10 to this variable a. So we can specify it as init and open the curly braces, and within that you will specify the statements or the operations that need to be executed before the constructor is called. So if you see, the result will go something like, okay, we have some error. Okay, as we saw earlier, val cannot be reassigned, right? So we should make it as val. Okay, let's run the code again. Yeah, as we can see, like first the object will be created. During the creation of the object, parameters 1 and 2 will be passed. After the passing of these two parameters, so we have the value of a as 1, right? So 1 plus 10 is equal to 11. 11 plus 2 is equal to 30. So this is our result. So this is how init block is used during the before the constructors. Okay, this was regarding the init block. Okay, next we have something called as secondary constructors. So secondary constructors allow initialization of variables and also allows us to provide some logic to the class as well. So before we go through this definition, let's directly declare a secondary constructor. Okay, to declare a secondary constructor, we'll use this keyword called as constructor. And within that constructor, okay, for now, I will remove this primary constructor. Yeah, cool. So within this constructor, I'll specify the attribute or parameters name and also the data type. So I'll be specifying two parameters A and B, and both these parameters are of the type integer, right? Okay, I will declare a. Okay, I'll remove these things also. Things are getting messy, right? Yeah. Okay, I'll declare a variable called as result. Since it will hold store the values of the type integer, I'll explicitly mention it as integer. Okay, here I will specify something as result and I will add these two things. Then, and one more thing, you can have like more than one constructor. In secondary constructor, you can have multiple secondary constructors, right? Okay, now I'll specify something like A of the data type integer and B of the data type integer and C also will be of the data type integer. Here also I will store something like result is equal to A plus B plus C. So this is how you declare the secondary constructor. So basically you declare it using the constructor keyword. And then you will open the small brackets and within that we'll specify the parameter name and its corresponding data type, right? So after that we'll open the curly braces and within these curly braces we will be specifying the set of operations that need to be performed on these parameters, right? Okay, this is how you declare a secondary constructor. Okay. Now I'll declare another variable called as another object called as D and I'll pass three parameters. So let's see what happens. I'll print out the results. D dot result. So I'm basically just accessing this variable corresponding to each of these objects. So one more thing, like each of the object will have a separate copy of this variable result. So if you see, yeah, 1 plus 2 is 3 and 1 plus 2 plus 3 is 6. For this, we have just passed two parameters, right? So for that, Kotlin automatically invokes this constructor. And here we have passed three parameters. So Kotlin will invoke this constructor since it has three parameters. Kotlin will invoke this constructor. Yeah, that's it about the secondary constructor. So let's go through the definition now. Secondary constructor allows the initialization of variables, but also provides some logic to the classes. So as we know, the primary purpose of these constructors is to initialize the variables, right? So even secondary constructors do the same. But since we are able to add logic to the constructors, it has secondary constructors helps to add logic to the class as well, right? Okay, this was regarding secondary constructors. Okay, next we have something called as inheritance. So what is this inheritance? So before we move on to the definition, as I said earlier, OOPS basically, object-oriented programming languages basically promotes reusability and reduces redundancy, right? So basically we can achieve this reusability using this inheritance. So what is this inheritance? So inheritance allows all the features from an existing class, or you can say it as base class, to be inherited or copied by a new class. And this new class is called as derived class. So to understand this, we'll go through one example. Okay, I'll clear out all of this. Let's start from scratch. Okay. Okay. Let's declare the class called as car. Here I will have one attribute called as color. I will assign it with the value red, and we'll have one more variable called as model, and I will assign it as e. Right? Okay. So I will declare one method called as drive, and print something within this. So that's it. Okay. Let's say I'm building a car called as flying car. Okay, even in flying car, the color, model, and this drive functionality will be same, right? So you can go like this. You can just copy this whole thing and you can paste it, right? So here's where it might go wrong. Like as the code definitions or the class definitions go larger, you can't, copy paste this whole thing inside another class. So that's where we will be using something called as inheritance. So inheritance is basically like copying or inheriting the characters of the existing class. So to inherit, I'll specify something like this, colon. After this, I'll specify the name of the class that I want to inherit. So in this case, it is class car, right? So after specifying the name of the class, I'll be using something like this. So it's basically like invoking the constructor of this class car. Okay, here, okay. Let's say I want to change the model. Let's see. I'll keep the color as red, but I want to change the model. So let's say I'll name something as fly. Okay. And since it is a flying car, I need to change this function, right? So I will go something like this. So it will be making this sound, but except it can fly, right? So this is how you inherit. But after flying, I will declare one more function called as land. In land, I will go something like landed successfully. Okay, let's create an object. Well, my car one. Say I want to create a flying car. Object of the type flying car and go something like this. Okay, let's try to print the model of the flying car. So I specify the name of the object. Then I'll go something like result, right? Okay, let's see. Okay, there are some errors popping out. Okay, we'll go by each of the two, like we'll resolve these errors one by one. So there's this first error called as unresolved reference result. Okay, sorry. We don't have a variable attribute name result, right, in this flying car. So it makes sense. I'll go model, then I'll try to run. Okay, next we have something called as final. So it cannot be inherited from. So what is this final? So basically by default, all the classes in Kotlin are marked as final. So what does this mean? So basically final means that you can't change the variable values or you can't modify or override the values. So in order to make a class inheritable or we need to use some keyword called as open. So which is saying like I am open to be inherited and you can modify you can modify or override the functions that I have. Like basically we have to modify this function right in the flying car. So we need to it's like instead of saying modify, we will be saying something called as overriding the methods. So first we need to make the class open, which suggests that I'm open to be inherited. So now I think it should make sense. Okay, since we are overriding the model, we need to make As I said earlier, instead of saying modifying, we have a fancy term called as override. So we are basically modifying the value of model, right? So we need to specify this keyword override. But we are also modifying this drive function. So we need to specify the same here also. Okay, now I think things should work. Okay, it again says, as I said earlier, in Kotlin, classes and even its attributes and the methods are final by default. But now we have just made the class as open. We need to make the attributes and even the functions as open in order to override it. Okay, I have made the variables and the methods as open. Now things should work fine. Yeah, as we can see, this flying car basically inherits the characteristics of this normal car, and apart from inheriting, it just overrides the necessary attributes that it requires. So say I want to print out the model of the color of the car, say color. So even though we don't have something called as color variable within this flying car, but still it will work. Let's see. Yeah, as we can see, the even it has printed the colors. So basically, this flying car will contain everything. This normal car, and in addition to this, it will basically override these two attributes and functions respectively, and it will add one more function called as line. So that's how you achieve inheritance in Kotlin. So instead of copying this whole thing, we basically reduce the code, right, within this flying car. So that's how we achieve the reusability in OOPS, or object-oriented programming. So this is the same code that I typed out. Yeah, if you see inheritance, go through the definition. Inheritance says that it allows all the features from an existing class. In this case, we are deriving the features of the existing class car and it to be inherited by a new class. So our new class is the flying car, and it will contain all the existing features of the current features of this existing class. So this was regarding inheritance. So next up, we have something called as abstract classes. So if you go through the definition, it says that abstract classes are partially defined classes, and it contains partially defined methods, and it must be defined in the class that inherits it, right? So I think the definition is not clear. So we'll just go through a code example. Okay, again, we'll clear out all of this stuff. Okay, clear out this main function as well. Yeah. Okay, to declare abstract class, we use a keyword called as abstract. So abstract class car. Then I'll move on to the next one. Then I'll define an abstract function called an abstract function right, or you can name it as run. Okay, if you see, I'm not declaring the function body, right? So that's what makes the abstract classes special. We'll see like why it makes the abstract classes special in the later part. You now will declare one function, but here for this, I will declare the body as well. I'll say something like car stop, car as stop. Okay, this is how we declare the abstract class. Okay, if you see the definition again, they are partially defined classes. So if you go through this class, you can say that this class has been defined partially, right? Since this function does not contain its body, it's kind of partially defined, right? So we can say that abstract classes are partially defined classes with partially defined methods. And if you see it again, these partially defined methods must be defined in the class that inherits it. Okay, what does that mean? Okay, now I'll declare a class called as Honda. So it will basically inherit this class car, and I will specify this small brackets. Then I'll move on to the next line. Okay. To override a function, we need, so since we need to define this function, right? So we will be overriding this function. And I will print something like Honda is running safely. Okay, let's create an object where my car run, and I'll create an object of the type Honda. Let's try this. My car one dot run. My car one dot stop. Okay, let's run the code. Yeah, if you see the output, it uses the print statement from the overridden function. It says Honda is running safely, and then for the stop function, it will call the stop function from this class, right? So if you have some doubt like why we are not specifying something like open keyword here, so basically abstract classes are not final. So you do not need to specify the open keyword as we did for the inheritance. Right, this is how you achieve or declare abstract classes. So now I think this definition makes complete sense. So they are basically, to summarize, now abstract classes are basically partially defined classes, and the partially defined methods must be defined in the classes that inherited you, right? So this is for regarding abstract classes. So next up, we have something called as interfaces. So what are these interfaces? Interfaces are nothing but the custom types that cannot be instantiated directly. Instead, these define a form of behavior that implemented types have to follow. Yeah, the definition is quite complicated. Let me simplify it. Yeah. Okay, to declare a, okay, we clear out all this stuff. To declare interface, we need to specify the keyword interface. So let's say I declare the interface called as four-wheelers. And within that, I will just declare functions, start and stop. But one thing to keep in mind is you can't define a function within in an interface. Like you can't go like dry. If you try to do this, the compiler will throw some error. Let's run. Okay, this. Okay, just yeah. Okay, so since this interface has not been called anywhere in the main, it's not being, so the compiler is not throwing any errors. Okay, we'll see this. For now, I'll comment it out. Okay, let's say I define a class called as car, and this class inherits this interface, four-wheelers. Okay, after inheriting, I specify the curly braces. So we need to override these functions, right? So I'll just copy the function definition. I'll be overriding this. Inside this, I'll just print started. And we'll be overriding one more function that is called as start. And I will copy the same, but I will change the function name here, stop, even the body, right? Okay, this is how you implement an interface. So for that, now I'll declare an object, my car1, the type car. So we call the objects methods like start and stop. So let's run this. Yeah, as expected, it's printing this respective statements. So let's see what happens if we declare a function within this interface. Okay, let's try to call this. Okay, it works. So this was regarding interface. So basically, interface you can have like abstract function as in just the definitions of the functions. And after inheriting, you can override the functions and define the function body, right? It is first regarding interfaces. So next up, we have something called as enums. So enums is nothing but a list or named list of constants. So why do we need this enum? So basically, let's say you're building an application. In that application, you have some variable named as day, right? So the day can occupy only 7 values, right? Like the days of the week. So you can go like, I will assign a string to the variable day. But if the string is some random string, it might, crash the entire app. So in order to restrict the values that a variable can take, we can use these enums. So let's see how these enums work. Okay, I'll clear out all this. Okay, to declare a enum, so we'll just declare a class base. Then after declaring this class, we will prepend the this definition with the enum keyword. So it will contain something like Sunday, Monday, Tuesday, Wednesday, and Thursday, then Friday, then finally Saturday, right? So this is how you declare a enum. So our previous approach was to declare a just variable and assign it with some string, right? Say Monday. Okay, this thing works. What happens is, even if you make a single typo, this might crash the entire app, right? Like this value will, guide the processes in the app. So it might crash the entire app. To restrict the values a variable can take, we will be using enums. So we restrict this variable to just to take the values that are present within this enum or a list. So I will go like day is equal to assign a enum. First, you need to specify the name of the enum days. Then after this, you'll be able to access the values. Say I want to say Sunday. Okay. This is how you declare a enum and assign it a variable. So if I print out this variable, so as you can see, it prints Sunday, right? So this is regarding enums. So to summarize, it's basically used to restrict the values a variable can take out of a small set of possible values. So this was regarding enums. So next up, we have something called as lambda functions. So this is a pretty important concept. So this will be forming the basis for the upcoming sections. So this is what Jetpack Compose uses mostly to build the apps. So it's very important to understand this concept, right? Okay, before moving on to these lambdas, let's revisit the functions. So this is how you declare a function, right? First you specify the keyword fun, then you specify the name of the function, and after specifying the name of the function, you specify the parameters and its corresponding data type. And after specifying this, in order to specify the return type, you will be using something like this, and this is the return type of this function. So this is basically function with parameters and also return type, right? Okay, so what are these lambda functions? So a simple definition is a lambda function is nothing but a function without a name. I think this definition is quite confusing. Okay, let's see what is this lambda function. Okay, in order to declare a lambda function, okay, first we will just declare a normal function add. It takes two parameters, a and b, the type integer. So it will basically return an integer, right? So in order to specify the data type, we'll be specifying it after the colon. So this is how we declare a normal function. Okay, let's say declare a variable and call this function. We pass two parameters. So after passing this, I'll print out the result. Okay, if you see, the result must be 33 as expected. So this is how you declare a normal function. So what is this lambda functions? Lambdas, right? Lambdas. So as the definition says, lambdas are nothing but a function without a name, right? So basically we'll just take this function and copy it here. So as per the definition, it says it's a function without a name. So we'll just go through the definition. So we'll just remove the name of this function and the keyword. So after removing the name of the function and the keyword, I'll also remove the name of the parameters. So it basically looks pretty plain, right? Okay, after this, but in lambdas, we'll be specifying the return type using this arrow symbol. So after this, in order to, okay, I'll clear out this. Okay, this basically looks like a function, but without any name, right? So in order to declare the body, I'll open the curly braces and it will be assigned using this assignment operator. So I specify the name of the parameters within these curly braces and the function body will go after this and that will be specified after this arrow symbol. So since it is a add function, I will add the two integers. So this is the return type. So if you can see, this thing kind of looks similar to these parameters and this is the return type and it is specified this a plus b. So since it is returning something, we need to store it somewhere, right? So before that, so if you're thinking like, how do we call this nameless function? Of course, we will be naming it we'll be naming this. So instead of just naming the function, we'll be basically storing the function in some variable. So let's say I call this function as sum, but I'll be not storing this function using this assignment operator. Instead, I'll be using the colon operator. So this is how I declare a lambda function. Okay, if you run this code, so okay, let's call this function sum. So this is the name of the lambda function, and I specify the two parameters 1 and 2. Now I'll print out the result. If you see, it's pretty similar to the previous function, right? But it looks short and concise. Like it basically reduces the code. It's more readable, right? So this is how I declare a lambda function. So to summarize, first you took the function, right? You took the function. Then since the definition says it's a function without a variable name, you will remove this variable name of the function. And after removing the name of the function, you will be removing the name of the parameters. Then to specify the return type, you will be specifying after the arrow symbol. Then to declare a function body, you specify it after the assignment operator. And you will also remove this return statement. Then within this curly braces, you will be specifying the uh, parameter names, and after the arrow symbol, you will be specifying the return type. So this is how we declare a lambda function. To call it, we need to have some name, right? So we'll name it as sum. So that's it regarding lambda functions. Okay, this is a normal function. This is a lambda expression with a return value. This is a return value, right? Okay, there's one more function. So this is a normal function that returns nothing. If you have some knowledge regarding C language, in C to specify, we'll be returning nothing. We'll be specifying it with the keyword void, right? Similarly, in Kotlin, we have something called as unit. Unit basically says that we are returning nothing from this function. So this is how we declare a lambda expression without a return value. Okay, next up we have something called as trailing lambdas. So So what is this trailing lambda? So a function can be passed as a parameter to another function. So as simple as that. So basically you're passing, integers, strings as a parameters to the functions, right? But Kotlin allows us to pass even the functions to the another as a parameter to the another function. So let's see a demo of this. Okay, clear it all of this. Okay, let's just keep this lambda function. Okay, now I'll declare a trailing lambda. Okay, let's say the name of the function is demo. I'll pass a message which is of the type string. So as I said earlier, we can pass even the functions to the as a parameter to another function. So I'll name the parameters, the function as the parameter. And to pass the function, we'll be specifying something like this. And after this, you'll specify an arrow operator. And after the arrow operator, you specify the return type that you will be expecting from this passed function. So I specify it as int, right? Okay, within this function, I will print this. Yeah. So this is the message that we have passed into this demo function. So in order to invoke this function, so let's say introduction, this is the output of the function that is passed as an argument. So in order to call the function within this print statement, as expected, we should use this dollar operator, and within this we should specify the curly braces, and within this curly braces you should call this function. So this is our function name, right? Yeah. Function as a parameter. To call the function, we should be using this small brackets. Okay, this is how you pass a function to the another function. Okay, now let's call this function. Okay, I will be assigning this string as say hello. Okay, here's the thing. You can either specify the function here itself, or Kotlin allows one more syntax. You will be using something like these curly braces. Within these curly braces, you will be specifying this function as the parameter. So basically, we want to pass a function, right? I will be passing this function sum. So I copy this function name here, sum. And since this expects two parameters, I'll be passing the two parameters, 1 and 2. So that's pretty much it. So this is how the trailing lambdas look. So we'll pass the first parameter message. And in order to pass the function as the actual parameter, you open the curly braces, and within these curly braces, you will be calling the function. In this case, it's our lambda expression, right? So if you run this code, yeah, as expected, this is the message that we pass, and this is the output. Okay, we have something. Function dot. Okay, this was the output. Okay. So as you can see, we missed out one curly brace here, so it's printing some object. Yeah, let's run it again. Yeah. So this is the parameter that we pass as the message, and this is the output of the function. So 1 plus 2 is 3, and this is the output 3. So this is how we pass a function as a parameter to another function. So this is it regarding trailing lambdas. So to summarize, the function can be passed as a parameter to another function. So that's it for this session.
Thank you, Manjunath. The attendees may now clarify their doubts by turning on their mics or putting them in the chat box.
Do you guys have any doubts?
Even the smallest, the silliest doubts are welcome. It may be very significant for your learning.